Welcome to Statistics for Surveys, Session 2 Tables, Optional Segment 3, Number of Bins. In this segment, I'll try to explain why the number of bins matter and how you can actually determine the number of bins. It's useful if you watch Session 2, Segment 4, Table for a Scale Variable. In this segment, we'll discuss two new terms, square root choice and Sturgers rule. Why is the bin choice actually important? Well, as it turns out that by creating bins we lose a little bit of information, and therefore if we later on create diagrams from these bins, we are actually not showing all the data, we're simply having a smaller segment of the data because we classified everything into bins. And because of that, the pattern that emerges might be different. Here's an example of 4 diagrams, each coming from the same set of data, but using a different number of bins. If you look at the first one, where 77 bins are actually used, there's not really much that we can see. The only thing is that there's a lot of people here and not so many on this side and also not so many on that side. If we look into diagram 2, where there are 20 bins being used, we can actually see there's somewhat of 2 peaks emerging in here. If we go for diagram 3, where there are only 7 bins, then the 2 peaks are gone and it's just a larger peak around here. If we would only use 3 bins, such as in diagram 4, then there's hardly anything that we can really tell from here besides that this one is really low. So which one is actually showing the correct one? Diagram 2 might be the best choice, but 20 bins is still a lot. So choosing the right number of bins can be quite important because otherwise you lose too much information, such as in diagram 4, or the other way around, you have way too many bins and don't actually see anything that's kind of interesting. Unfortunately, there is not a single rule on how to decide for the number of bins. I've had a look through a few textbooks I had laying around and constructed the following frequency table. Here you can see that, for example, 10 textbooks that I looked at indicated to use 5 to 15 bins. There were 2 that actually said, well, around 10, and there were 6 that didn't have any guidelines. There were also 6 textbooks that actually mentioned a specific formula. 3 of those mentioned the square root choice, 2 of them Sturgers rule, 1 Kelly's rule. So there are actually a lot more different rules and people who came up with different rules for this. If you're really interested, I suggest you Google a little bit on it and I'm sure you can find a few more. I will limit myself in this course to the square root choice and Sturgers rule that I'll explain both on the next slide. The square root choice is actually, as the name implies, to take the square root out of the total frequency, round this then up to the nearest integer. So if you have 150 scores, so your total frequency is 150, then you take the square root out of this 150, which is roughly 12.25, and then you round this up, so 12.25 gets rounded up to 13. Now, Sturgers' rule is slightly different. He suggests to take the logarithm base 2. He actually wrote down a number himself, but it's clear from the text that he meant logarithm base 2 out of the total frequency, add 1, and then round this up to the nearest integer. So again, if we have 150, then we take the logarithm base 2 out of this 150, which is roughly 7.23. We then add 1, so that becomes 8.23, and then we round this again up to the nearest integer, which is 9. So if we have 150 scores, then according to the square root choice, we should use 13 bins, while according to Sturgers' rule, we should use 9 bins. Once you know your number of bins, it's actually time to create the bins. In general, you therefore need to determine your maximum score. So let's say we have as an example that the maximum score is 12.28 gram or kilogram. Then determine the minimum score, and let's say again in an example that is 2.34 kilograms. Subtract these two to obtain the range, and if you plan on using bins with a smaller than sign, so not smaller than or equal to, then add one more to the range. Now in this case my range is that 12.28 minus the 2.34, which gives me 9.94. However, because I'm planning on using bins like this, I need to add one more, and with one more I mean here the measurement precision, which is 2 decimals. So in total I get 9.95 as my range. Then divide this range by the number of bins. So from the Sturgers rule, we saw that for 150 we need 9 bins. So 9.95 divided by 9 is roughly 1.10556, which therefore actually gets rounded up. The 556 gets rounded up, but even if it was 446, I would round it up to 1.11. Then use the minimum score as the lower bound, add the bin size, and then keep on continuing to create your bins. So in my example, my minimum score was 2.34. So 2.34 plus the bin size, which was 1.11, gives me 3.45. So my first bin is 2.34 until 3.45. The next one is then 3.45 until 4.56, etc., etc., until I reach the last bin, 11.22 till 12.33. Note that the last bin indeed captures the maximum score. After you created these, you can actually try to see if you can perhaps make the bins a little bit nicer by using some round numbers. Perhaps I can use, instead of 1.10, I can use 1.2, or perhaps even just 1, or perhaps 1.5. As you might have noticed, the rules aren't so strict and there's so many different rules on the number of bins that 1 or 2 more or less bins is often not a big problem.